We'll talk about ions, I-O-N-S. So first, what is the meaning of ions, ions? These are the particles with charges. They have charges on them. Atoms with charges. How many charges are there? Two. Yes, two. And what are these two charges?
Negative and positive?
Negative and positive. Yes, these are the only two charges which we'll be working on.
Canine.
Yeah.
Canine.
The positive charges are
Anion.
cation. Cation.
Oh,
The
cation.
positive.
Okay.
Cation. And the negative is
Anion.
anions. So, and what are the two charges present inside the atom?
In nucleus.
Inside the nucleus, what is there inside the nucleus? What charge is present?
Positive.
Positive. What charge is present around the nucleus?
Negative.
Negative. And if I look at that atom here in the periodic table, what is the net charge on the atoms?
0. No
0.
charge.
Why is it so?
Because the positive and the negative charges cancel and neutrons have no charge, so
Because positive and negative charges are equal in number, right?
Yeah.
So they cancel out each other, right? Okay, good. So it means in the cations and anions, the positive and negative charges are not equal. Am I right? That's why they have some charge on them. Okay, good. Now, can you tell me in cations? Okay, first of all, answer this question that in the atom, what are the particles? The protons, neutrons, or electrons? Which particles can undergo a change?
electrons.
Electrons, yes, electrons. So it means when these cations and anions are formed, then it's just the change of electrons. Am I right?
Yeah, the adding or subtracting of an electron.
Yes, so it means either the electrons are added or the electrons are removed, right?
Yeah. Yes.
Okay. Now look at the cations. In the cations, what is more, the protons or the electrons?
The protons.
Proton.
You're getting it, Kyra? And in
Yes.
the anions, what is more?
Electrons.
Electrons. Very good. Right. So in the cations, the protons are more by adding more protons or by removing electrons?
Removing electrons.
Moving.
Cations are formed by removal of electrons. Please write on this. Not by addition of more protons, right? And anions are formed by addition of electrons. Okay. Aditi? She is still connecting. Aditi, you can hear me, Aditi, now? Change your name, please. Aditi?
I think she's.
Hello.
Start your video, Aditi.
Yeah.
Aditi, what happened?
There's tech issues.
Say again?
There's tech problems.
Tech problems. Okay. Good. So children, can I give few minutes to Aditi? By the time it's a revision for you also. Okay. So Aditi, we started the class, but somehow I was thinking about you today, yesterday also, and I felt that you were not comfortable in the last class. Am I right, Aditi?
I mean, I didn't get some of it.
Yeah, but why didn't you ask questions? So somehow I could make out that you were in trouble in the last class. So children, today we'll be focusing more on Aditi, right? Because she is a new student also, right? So we'll help her. And Aditi, you are free to talk to me anytime. And please ask your questions. And ask questions from me, ask questions from Avni and Kyra. They will also help you. So first, I'm asking questions from Aditi now, children. And by the time you work out these questions. Sulfur, polonium. Kyra and Avni, can you just type the answer in the chat, the number of electrons, protons, and neutrons, and check each other
Sure.
answers? Okay? And give me few minutes. Aditi, it's you and me only now. Okay? So look at the whiteboard, Aditi. This is an atom.
Okay.
Because you see that if you start losing the ground, you will start hating the subject, which I don't want. In the atom, Aditi, what are the particles? You remember the particles? Answer it.
Um.
Subatomic particles inside the atom?
Oh. It was electrons, neutrons, and protons.
Yeah. What is there inside the nucleus? What is there inside the nucleus?
Neutrons and
Nucleus.
protons.
Yes. Say again.
Neutrons and protons.
Neutrons and protons. That's what you are saying?
Yeah.
And what is there outside the nucleus?
Electrons.
What is the charge on the electrons? Charge on the electrons? Negative?
Yeah, negative.
And positive. Right, Aditi? And neutrons?
Oh, sorry, you cut out for a second. And
Oh.
neutrons is
Mhm.
positive?
No, neutrons are zero. You have some internet problem last time also? Okay. Can you ask your father to check it, okay? We should have a smooth
Okay.
internet. So electrons
Okay.
are negative,
Yeah.
neutrons are zero, and protons are positive. You heard this, Aditi, very clearly?
Yeah.
Okay. Now look at this aluminum. This one, Aditi. I'm writing a symbol here, aluminum 1327. This 13 is the atomic number. Atomic number. Atomic number is 13. So can you tell me how many protons are there?
13.
Yeah, 13. So plus 13 nuclear charge, agreed?
Yeah.
Right? Okay. Now, is there any charge on aluminum right now, Aditi? So how many electrons are there? Same number. Because there is no
13.
charge on this.
Yeah.
So what is the net charge? Plus 13 minus 13, 0. Right?
Yeah, 0.
How many neutrons?
Yeah.
Can you calculate the
0.
neutrons?
Oh,
Proton plus neutron is 27, right?
yeah.
So neutron is?
Neutron is 14.
Very good, my girl. 14. But neutrons have no charge, right? Now, before you enter the class, I introduce these girls with the ions. The word ions. Ions means charged atoms. Atoms with charges on them. Charged atoms. Like right now, these atoms are neutral. So girls, you have done the checking of your work. Both of you are
Yeah.
right? Okay, thank you very
Yeah.
much. Now come back. We are going to review this, and give me 1 second. I'm back, girls. Sorry. So, Aditi, when you enter in the class, before that, we were talking about ions. And ions are charged atoms. And there are only two charges. What are these two charges? Aditi, answer it. What are, okay, you will not answer, girls. She will the only one who is interacting with me. Two charges, what are those? Positive and
negative.
when the atom has a positive charge, then it is called as a cation. Aditi?
Okay.
When the atom has a negative charge, then it is called as an anion. Right? These are the names, cation. So what is a cation? Cation is something with the positive charge. And what is an anion?
Negative charge.
Negative charge. Right? Okay. Now, in the atom, what can you change? Can you change protons and neutrons which are inside the nucleus? Can you change that? Protons and neutrons? Remember last time Avni was asking a question that why protons and neutrons are in such a small volume? And I said that they are very strongly bound to each other. If they are strongly bound to each other, can you pull them apart?
No.
So what can you pull apart? The electrons.
Trans.
So you can only change electrons. You cannot change protons and neutrons, right? It means the one which is a cation is formed by removal of electron, and the one which is as an anion is formed by addition of electron. I'm sure that this definition is not clear to you, so don't worry. We'll do examples. Ready? Okay, girls, now we all are participating. Thank you for your time, Avni and Kyra. Thank you very much. I have seen that Aditi is slightly troubled, so we have to pull her up so that she can learn chemistry with love and dedication. Ready, children, now?
Yeah.
Okay.
Yes.
So this is the symbol, this is the atomic number, and this is the mass number. It's a neutral atom right now. Neutral, no charge. Now, do you know these elements? You know these elements?
Yeah. Noble gases?
Yes, these are called as noble gases. What else you know about them?
They're all neutral?
Everybody is neutral, Avni.
Yeah.
Everybody is neutral. What else you know? Okay, let me tell you, and that should get printed on your mind. Aditi, these noble gases are unreactive. They don't react. They are unreactive. Unreactive means stable or unstable? Answer this, all of you.
Stable.
Unreactive, stable.
Unstable.
Some
Stable.
wait,
Stable.
dear, stable. Unreactive are stable. They don't react, right? So please write down. Unreactive are stable. Stable means they are lying there, not doing anything. So it means they are stable. Aditi, you are understanding this? Unreactive are stable. Okay. So these are the stable gases. These are the only stable elements in the periodic table. These are the only stable elements. We do have some more, but these are the most stable elements. Can I write most here? Most stable. I told you to take a print out of your periodic table, keep highlighters, and keep writing on the periodic table only. Highlight and write. Okay, so now Aditi, Karya, and Avni, what is more okay with you? Being stable or being unstable? You want to be stable in life or unstable?
Stable.
Oh,
All of us want to be stable in life. That's why you are learning. Your parents are spending money, you are also working hard. Why? Because in future you want to be doing something good so that you can be stable in life. Am I right? Okay, so stable is liked by nature. Write down this line, children. Stable is liked by nature. Liked by nature. Nature, natural forces around you. Some people they call it as God and all these things, but that's nature, which is the driving force for everything. So nature wants things to go in the direction of stability. So what nature wants, children? Stability. Yeah, people they say that, oh, in the coming time, this will happen, that will happen. But remember one thing, nature will not take you in the direction of instability. Never ever. Nature will always push you in the direction of stability. Right? Okay. So that's the nature of the nature that is looking up for stability. I said these are the gases which are very stable. Noble gases. They are also called as inert gases. Aditi, inert gases. One second, children. Actually, you've let me put it here. Like this. Okay. Inert gases. They are also called as inert gases. Noble gases, inert gases, unreactive gases. But these are the names, noble gases and inert. Inert means, what can be the meaning of inert? Unreactive. Inert means unreactive. Aditi, is it okay?
Yeah.
Aditi, keep asking your questions. Okay, don't hesitate, my girl. Okay, now if these are stable, can you tell me how many electrons are there in helium? You can see these are the atomic numbers, right? So how many electrons in helium? You know,
two.
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 You remember that atomic number and mass, number of protons are same because these atoms are neutral. So 2 electrons. How many electrons in neon, Aditi?
Um,
How many in argon?
18. 36.
Xenon? 86. Children, is it okay?
Yes.
Yeah.
So it means elements with these electrons are stable. Somehow these numbers are called as magic numbers in chemistry. Magic numbers. People are still trying to figure out that why these gases are stable with these electrons. Why these electrons can make now we know the reason also, but still some very big questions are still there in the nature, right? Mysteries. So magic numbers, these are magic numbers. Now elements with these electrons, elements, we don't have elements with these electrons, right? So ions, ions means cation, anion, with these magic numbers, with these electrons, with magic number of electrons, magic number
I
of
thought ions were unstable though, right? Ions?
no, they are stable. Magic number of electrons are stable. Ions are formed to become stable.
Oh, because they're unstable in the beginning. Okay, yeah.
Yes, yes. ions are formed to become stable, right? Now let's see how. Ready? All of you? Because I'm going to discuss plenty of questions. So please don't hesitate in asking questions. Let's pick up sodium metal. Sodium. Sodium, I'm giving you a symbol here. 11 and 23. So how many protons in sodium? In this sodium?
11. 11.
11.
11.
How many electrons?
11.
11.
So proton plus, electrons minus. What is the net charge?
0.
0.
0.
Yeah, Aditi, getting it? Good. Now, what is the magic number closest to this 11? 11 electrons. What is the
10.
magic number?
10.
2, 10, 18. Which one? 10.
10.
So how can I achieve this 10? By losing one electron or by gaining some electrons? This is
By
11.
losing one.
By losing one.
Minus 1.
By losing one. Let's take out one electron from this sodium. Out. This is out. See the arrow? This is neutral, no charge. Now one electron is out. So what is there is no change in the atomic number. It's still 11. Still 23. So how many protons? Still 11.
11.
Yeah.
How many electrons?
11.
10.
10.
What is the
10.
net charge?
1.
1.
So this sodium has a plus charge. It's not
Yeah.
neutral.
Yeah.
Now
Yeah.
this is an ion.
Yes.
And is
Yeah.
this ion more stable than this sodium?
Yeah.
Yes.
Yeah.
This ion is more stable than sodium. What is the reason? Because it's exactly like neon. Its number of electrons are like neon, right? Avni, you have some question in mind? You
Yeah. I was thinking that how does it exactly lose or gain an electron? Because like if it knew how to do it, like, oh, I have to get to this magic number, like if it had a brain like that, then wouldn't it always just be like close to neon and never be like sodium?
Yeah, it is
So
never
then
never be like sodium.
Yeah, but so then how does it lose an electron? Is it because like it bonds and then loses?
Yes. I'll explain you. She is thinking very good, and I will explain you that. But are you clear about this? Sodium is going to lose one. Now she's
Yeah.
saying, how is it going to lose electron? I know she's in agreement that this sodium plus is more stable because its number of electrons are same as neon. But I have one question before I answer her question. I didn't change the symbol of sodium. Symbol is still Ne. I didn't write it as neon. What can be the reason?
Because it still has
Still the
proton.
same like atom. It has the same mass number. It has the same atomic number. You can't change the symbol
Perfect.
because it's the
Perfect.
exact same one.
So it is the protons, number of protons, which are going to decide the symbol. Please write on this. Number of protons, which is also called as atomic number, decides the symbol of the element. Aditi, protons are not changing. Am I right?
Yeah.
So because protons are not changing, so that's why I didn't change the symbol. I'm talking about it's like helium, or sorry, neon. It's like now it's like neon, but I'm not writing it as neon. I'm still writing sodium. Avni, you are slightly troubled. Is everything okay?
Yeah.
Okay, good.
I have a question.
Mhm.
Why couldn't we just make the protons more less? Like, do they always have to be the magic number to be an ion, or can there be another way to make it an ion?
You're talking about why can't we add or remove protons, right?
Yeah.
Okay, Aditi, Avni, can you answer? Because we discussed this last time.
Because they're too tightly bound with the neutrons, so you can't
So-
break them. And
Yeah.
also, if you break them, then it won't exactly be the same symbol because it'll lose its atomic properties.
But you
Yes.
can break electrons.
Yes, you can break electrons. And Avni, she used very refined language because she is reading books also. So make it a habit of reading book. So if you want, I can give you a booklet for what we are learning. Okay, I'll send you a booklet for that. Okay, on
Was it
the.
also already one, like there was a YBTC book?
No, I'll send you better than that. YBTC is in brief. So the one you are learning, I'll send you one chapter only. So I'll send you small topics which you can read from that book. Okay. So YBTC, yes, definitely. I'll give you the booklet. I think Aditi didn't have that. So I'm back to my what we were discussing. Yeah, what Kyra asked, that why the protons cannot undergo a change, and Aditi answered it because protons and neutrons are very strongly bound. Then uh, Avni answered and Aditi also answered it. Okay, now any question from that? Because they are strongly bound, so large amount of energy is needed. But children, do you remember that I was talking about nuclear changes and chemical changes?
Yes.
So if you are changing the protons, then it's a nuclear reaction. And nuclear reactions, they involve a large number of energies, which generally we cannot give easily. So everything around you, inside you, is a chemical change. Just the number of electrons are jumping in and out. That's it. But anything which is a nuclear change is a very difficult, very large amount of energies are released and required, like sun. Sun is a nuclear reaction. So Kaira, your question is answered now very clearly.
Yes.
So when you talk about the change in protons, I want all you three to retain the word nuclear change also. Aditi, you're getting it? So if
Yeah.
somebody is talking about change in protons, oh, you can tell, oh, you're talking about nuclear change, which is very difficult. This is a nuclear reaction. It's a radioactive reaction. It is the reaction taking place on the surface of sun. Remember these points, right? Speak like this at that time. Okay, good. Now back to the question of our, I think Avni asked a question. Sodium is losing one electron. Now look at this. These electrons are not coming in the air. Remember, children, they are not in the air. Look at this chlorine. What chlorine can do, children? It has 17 protons, 17 electrons. The net charge is 0. So what do you think? What chlorine can do? Can it be like neon or can it be like argon?
It could be
Argon.
an
Argon.
argon because it's
It
more
could be
easier
argon.
to get to.
Also
You don't have to lose or add any more electrons.
No, it can do only one of them, either lose or
Uh,
gain. What do you think? What can it do?
gain. Gain.
Gain
Gain, yes.
is a bigger number.
Yeah, because now the protons are still 17, but after gaining electrons is 18 electrons, right? 18 like argon, 18 magic number,
Yeah.
right?
Yeah.
So what is the
Yes.
net charge?
Minus.
Negative one.
Negative one.
Negative
Now is
one.
now it's an ion, children. It's an ion, right? With the same protons, so symbol is not changing, but now it has a negative charge, correct? Now, Avni, your question is answered now. Sodium is not going to lose electrons in the air. So sodium is always going to lose electron to a chlorine or to some
Will
other
become salt.
anion. Yes. So now you know this compound, sodium chloride, the table salt which you eat, table salt.
Yeah.
Now in this sodium chloride, sodium is plus and chlorine is minus.
Oh, which is why they bond. Okay, yeah. That makes
Now they are
sense.
attracted. They are
Yeah.
attracted. Plus and minus, very strong attraction in nature. That's why they are solid also. They are strongly attracted to each other, right? Aditi,
Yeah.
you are getting
Yeah.
it? Now, Aditi, if I say which one is more stable, sodium or sodium plus?
Sodium plus.
Which one is more stable, Cl or Cl minus?
Minus.
Okay, if I ask you, Kyra, that out of sodium, sodium plus, which one is available in the nature?
Sodium plus because it's more stable and
Yes.
stable is liked in nature.
Yes, stability is liked by nature, liked by nature. Very good. So sodium plus is found as sodium chloride in the sea water. In the sea water, plenty of sodium chloride is there. Sodium bromide is there. Sodium iodide is there.
That's why the ocean's really salty if you
Yes.
ever got it.
Yeah, good, good. Because in the ocean we have plenty of salts. Even the
Yeah.
rocks are made up of salt. There also, rock salt, you must have heard about it.
Yes.
So all these are ionic solids, right?
Yeah.
We are good with this?
Yeah.
Okay. So that's the story about sodium, that it loses one electron. Now let's talk about the other one, which is strontium. Strontium. What do you think strontium can do?
It can go to 36 because it's more closer.
Go to krypton.
Krypton, yes. Aditi, speak loudly and clearly, okay? You're a smart girl. I still remember when you joined the class, you were asking so many questions. Now I think you are slightly troubled because few things you are missing. So don't hesitate. Be loud, clear, and ask questions. Krypton, this one. Strontium would like to be like krypton. Why not xenon? Why not argon? Who is going to answer?
Because I think
Because
it's like
Because
they're
it's closer to Krypton.
yeah, it's
yeah,
closer.
Krypton is more closer and the other ones are way too far. So like you're gonna have to either lose so many protons for
No, protons
You
come
won't
out of.
get attracted.
I mean
You won't get
electrons,
attracted.
sorry, electrons.
Electrons, yeah.
You're gonna have to lose many electrons or you're gonna have to get more
Gain many.
electrons.
Hmm.
So you might as well just do it with krypton and
But
just
why nature is not permitting us to gain so many electrons and lose so many electrons? Why nature is against of it? So children, in the nature, in the nature, the money, the way you use money, that money is energy. Energy. And when you say element wants to lose electron, gain electron, all these are energy bases. Losing so many electrons, the energy needed is more, large amount of energy. Gaining so many electrons, again the energy is difference is very large. Nature doesn't want to go in the direction of high energy. Nature doesn't do any work in which large amount of energies are involved, because if those things are happening, then it's volcanic eruption, earthquakes, which is harmful, right? Which makes everything, something is unstable. Why this earthquake is taking place? Because the inner plates of the earth,
Like
they are
they're
unstable.
going over. They're just going
they're
Yeah,
like
over.
rubbing against each other, so it just
yeah, so
makes.
they slide to become stable. Like you are
Yes.
sleeping and you are sleeping at one side, then in the night you want to turn in other side. The reason? Because you feel more relaxed. So in the same manner, these plates, the earth plates, they move, hit each other. At that
But when
time,
it does that, it makes like an
earthquake.
earthquake because like it's moving.
Is moving. Yes. Okay, so nature is always looking up. Please write down. Nature is always looking for low energy. Low energy. Write down this, children. This is something which I will make you understand more and more, and you will learn chemistry with these things. Nature, low energy. And low energy means stable. Low energy means stable, right?
Yeah.
So anything with the low energy is more stable. So which one has high energy? Sodium or sodium plus?
Sodium
Can you
plus.
repeat the
Sodium
question
plus.
again?
Which one has high
Sodium.
energy? Sodium or sodium
Sodium.
plus?
Sodium.
Sodium has high energy. See? Without even knowing the energy, just by looking at the magic number 10 and understanding of the magic number, we can easily predict that sodium metal is much higher in energy than sodium plus. So nature doesn't have sodium anywhere. There's no sodium. What is there in the nature? Sodium plus.
Sodium plus. I have a question.
Mhm.
If we were to move sodium to argon, which I don't think would be the case, would it be more higher
More
sodium?
higher. Yes, yes. Going, oh, she has asked such a good question. Going from sodium to argon means sodium has how much negative charge, children? This is 11 and this is 18.
-6? No, -7.
-7.
-7.
Aditi,
-7.
you have understood why we are saying -7? Oh my God, this species is very, very aggressive. So much negative, right? So much negative. So this is very, very high in energy. And that is the reason I never heard it. I'm teaching chemistry from so many years. I never heard any such thing. You're getting the point now?
Like, does it exist on?
No, no, not at all. Not at all. It is
So it's
not
just a fake.
anywhere. Hmm?
It's
Mhm.
just fake.
Yeah, it's fake.
Oh,
It's
oh
just
okay.
she's talking about, and I'm trying to explain that this one will be of very, very high energy. So it will not form at any cost, right? By the nature. I'm talking about nature only. So you cannot make it. So that is the reason uh, these type of things are not there in the nature. Kyra, is it clear?
Yeah.
Aditi? Good, good. So you said that strontium should be like krypton. That's what you said? Strontium? Where is
Yeah.
strontium? Here,
Um,
right? So what strontium can do to be like krypton? Is it going to
it
lose or
would
gain?
it would
Lose 2 electrons.
gonna
It will
lose 2.
lose 2 electrons. Oh, if it is loses 2 electron, it's going to have 2 plus charge, right? Thank you, baby.
Mhm.
Yeah.
It's going to have 2 plus charge, correct?
Yeah.
Why? Why this 2 plus charge is there? How many protons?
Because the protons will be balanced by the electrons, so the charge is plus.
Yeah, so how many protons are here in strontium 2 plus? How many electrons are there in strontium 2 plus? Can you give me the numbers, Aditi? Look at the atomic number 38.
38.
Okay.
So how many protons?
38,
How many electrons?
40, negative.
Oh no, 36. 36.
36. So
Oh
plus
yeah.
38 minus
Oh
36.
yeah.
So what is it?
Plus 2 charge.
+2.
Okay. Girls, let me tell you one thing. Aditi, I think, is the youngest here. Aditi, you are in which class?
I'm not youngest.
You're
I'm
not
the
young.
youngest.
Eldest?
Yeah. And I'm the youngest.
You're the youngest. Okay.
Yeah.
So you are in fourth,
I'm in 5th currently.
and Aditi, you are in.
She's in 6th.
Aditi, you are in sixth.
Yeah.
Okay, good. And Avni?
Yeah, I'm in 6th as well.
Oh, okay. Aditi, somehow you look so thin. You so start eating properly, okay? Because this is the time which is needed for gaining height, right? So if you eat properly, you'll get a good height. Kyra is of good height, I can make out. Touch wood. Kyra, that's really good, right? So try to eat properly, Aditi. Okay, don't trouble your parents in eating. I can I can tell you, children, she is troubling her parents. She's not eating properly. Am I right, Aditi?
No.
No? Okay, I'll ask them. Okay, so eat properly so that you can have a good height, good build. Later on, you can reduce the weight. Okay, so children, we are good with this understanding? Now I'm asking another question. Ready?
Yeah.
Selenium.
Okay.
What selenium can do?
It can go to Krypton.
Go to
Yeah,
Krypton.
Krypton. You
By losing or
You have
gaining?
to
gaining by
gaining
two
two
electrons.
Gaining 2 electrons.
Two
Yeah.
electrons.
After
Yeah.
gaining 2 electrons, what is the charge on selenium?
Minus -2.
Wait.
Minus
Yeah,
2.
-2.
Minus
So,
2. This is called as selenium, children, from the periodic table, right?
mhm.
Now, this is anion or cation?
Anion.
Ion.
What is anion, Aditi? The one, Aditi?
It was the negative charge. I
Yes,
think.
yes, yes. It's a
Okay.
negatively charged ion, right? So remember this, children, a negatively charged
Yeah.
ion will have a different name. It will have a suffix, "ide" in its name, "ide." This is not selenium. What is it?
Selide.
Yeah, replace "em" by "ide."
Selenide.
Speak again properly. Replace "em" by "ide."
Selenite.
Selenite. Yeah, it is selenite, right?
Oh, I thought you said it.
No, suffix. I said suffix "ide."
Oh,
Suffix. So I placed a suffix here, suffix "ide." Right? So every name will have a suffix "ide." The name will be like this: oxygen, oxide,
oxygen. Oh, yeah.
sulfur, sulfide, chlorine, chloride. You're getting it?
Oh yeah.
Okay. So let's do some more. So we are working with the anions and we are going to see the change and we are going to name them, right? So what do you think what iodine can do?
It can go
It can go to
Gain by 1 electron.
So gain one electron
N
means,
gain 1 electron, meaning
and it
it'll
will
go to
become
the magic number 54 and it'll come out as
I
negative
minus. One negative.
negative 1.
If it is gaining one
Negative,
electron, then one negative, right?
yeah.
Yeah.
If it is gaining two negative, you already know. We did the calculation. So how many protons in iodine?
54.
53. How many
I mean
electrons
53.
in this neutral
It'll
iodine?
oh 53.
53.
And in this I minus, how many protons?
54.
Don't do
53.
nuclear reaction. Who
Oh,
is saying 50?
53.
Yeah.
The
How many
electrons.
electrons?
54.
54.
This is plus, this is minus. So what is the net charge?
Yeah.
Negative 1.
Minus
Yes.
1.
Yes.
Negative 1.
Now name this. This is iodine. The one without any charge is iodine from the periodic table. What is the name of this one?
Iodine.
Iodide. Yes.
Iodide.
Yes. 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 Yes.
Sounds like Io died.
Iodide. Yeah. So suffix. I said the suffix. So in the anions, you will pick up the prefix from the periodic table and the suffix for that anion will be "ide."
Yeah.
That counts for all of them, or
All of them. But it has to be single atom. So we call them monoatomic ions. Mono. So generally is spelling is this monoatomic ions.
Wait, what do you call
Monoatomic.
mono? What do you call monoatomic?
Monoatomic means made up of only one atom. We are going to learn polyatomic also.
Okay.
This, you see, all these
Okay.
ions are made up of one atom. I minus has
Yeah.
only one atom. So these are monoatomic ions, right?
Yeah.
This is clear?
Mm-hmm.
Yeah.
Okay. So these are the names for the anions. Let's see the name of the cation. Cation. Their name will be as such, as in the periodic table. As in periodic table. Only thing that you will write ion in the last. Ion. You put a ion in the last. Like for example, check this calcium. What calcium can do? Calcium, children.
Calcium can,
To argon.
it can, yeah, it can go to argon.
By
So
It lose 2 electrons.
Losing
And
two
it'll-
electrons, and it'll have a positive charge.
Positive.
how many
Two.
positives?
Positive
2.
2.
And 2 electrons have come out, right?
positive.
Yeah, positive 2.
Hmm.
Yeah.
Right? Okay, so this calcium 2 plus
Yeah.
is losing 2 electrons. So what is the name of this this Ca? Calcium. What is the name of this Ca2 plus? Same as the periodic
Calcium?
table.
Calcium.
Calcium. No, 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 no.
Calcium.
Name as
Oh,
such.
calcium.
Calcium
Oh.
ion.
Oh, so yeah,
Oh,
calcium. Ion.
Calcium
Yeah.
ion. I thought you had to like combine them, like you had to do for iron.
Same. I thought you had to combine
No,
them
no, no.
too.
It's okay. It's okay. You are learning now. You are understanding. Cations, you are going to name it as such in the periodic table and then put a ion in the last to indicate that it's an ion. It's not a neutral atom. And anions, they have a suffix of "ide." Right?
Yeah.
Yeah.
Okay,
Yeah.
fine. You children are now smart. And we are left with very less time, but I think you are working very nicely, all or three. Aditi, you are comfortable now? Aditi,
Yeah.
okay, good. Please, girl, whenever you feel anything not clear, we can slow down, okay? But learning step by step is very important. And we are here for learning. Okay, now, children, I will teach you how to make ionic compounds. Ionic. Ionic means cations, anions, compounds. Ready? In ionic compounds,
Yeah.
we have a metal bonded with non-metal. You already know how to divide periodic table into metals and non-metals, you know? I think I
Yeah.
explained you
Yeah. Yeah, you
this
did.
one.
Mm.
Yeah.
It's like
Yeah.
a step cake.
Yeah, the
Yeah, the
side of it
staircase.
is
And
non-metal.
left side are,
Metals.
and right side are
Non-metals.
Non-metal.
non-metals.
Non-metals.
Okay, now answer my question. Left side are metals. What metals can do? What sodium can do? What calcium can do? What rubidium can do? Are they going to lose or gain?
Oh,
They're
they're gonna.
going to gain. Oh, sorry, they're gonna lose.
Hmm.
They're gonna
They're going to
lose.
lose.
Yeah, they can lose. Yeah, they have to lose.
They have to lose. Is the periodic table too small, children?
Oh,
I
No,
can,
it's okay.
because you are
it's
bending.
good.
I can make it bigger, no problem. Is it okay now?
Yeah.
Yeah.
Okay, okay, good. So this is the matters, non-matters division, right? I said what these metals can do. These are most strong metals. What they can do, you can see that they can lose
They
electrons.
lose. Yeah,
So
they
write
lose.
one more thing in your knowledge. Metals, they always form They always lose electrons and form anions or cations. What they can do matters.
They can cations.
Cations.
They lose electrons and they are always cations, right? Cations. So I can put like this M N plus. N plus means like sodium can lose how many?
1,
Magnesium,
Um,
2,
2.
aluminum.
3.
Yeah, like this.
3.
Yeah.
So this
Yeah.
N can be 1, 2, 3, right? But don't go for 4. I remember we were discussing that she gave us that example of sodium gaining so many electrons. So gaining and losing up to 3 is okay, children. Elements are happy to lose 1, 2, 3. But after that, energy needed is very large and nature doesn't permit. You're getting it? Getting too much charge is reactivity. Like I remember when I started with ions, and Avni said ions should be more reactive. But yes, they are more reactive if charges are very high. High charges, very reactive. Very reactive, very unstable. Very unstable, very high in energy. You're able to correlate this,
Yeah.
Kyra? Hmm.
Yeah, I
Okay,
have
so
a question.
mhm.
It's about like the converting into the magic numbers. What
Mhm.
about for silicon? Because it's like the atomic number is 14, but it can do that for neon
Or it can
and
go for
argon.
argon.
It can do for
Yeah,
either.
yeah, that's very
Yeah,
unique
it can do for
position.
either. So
So
can
it
it
can
do both?
it can lose or it can gain, but losing, gaining 4, I said is not permitted in nature so easily. So what it can do is going to share. That's why
Oh.
carbon is very unique. They are going to share.
So, are they
How
going to
they
become?
share.
Yeah,
Here.
they will
Yeah,
share
how
and they
they
will get
share.
the magic number. Like carbon will share 4 its electrons. It has 6, it needs 10. So what carbon is going to do? It will give us 4 electrons and it will get 4. So out of 6, carbon is giving, not touching 2, giving is 4, right?
Yeah.
And getting 4. Sharing means 1 from carbon, 1 from other element. 4 plus 4, 8. 8 plus 2,
8.
10.
10.
Yeah. So you will learn this, Kyra, right?
Wait, but if carbon's giving away 4
No,
to
no, it's
silicon.
not giving. It's sharing. Carbon is sharing 4 electrons. These are electrons of 4 electrons of carbon. Is going to share it with other element. Other element is also going to give 1. Like for example,
Then wouldn't
hydrogen.
But then wouldn't it be like 2 then? Oh no, you can put it
Now see how many electrons carbon has around it. Two are not participating. How many are there?
4, 8.
8. And these 2?
Then it would make 10.
And 10 is the magic number, right? And 10
Mm-hmm.
is the magic number. So write down this, Kyra, then it will be more clear to you. These elements, they lose, gain, or share electrons to get the magic number, to get the number of electrons to the nearest noble gas element. So these elements, they can lose or they can gain or they can share. Yes, yes, Avni.
So, this is kind of related to it, but like, since we know about the most stable ones, for the unstable ones, like, is it the actinides or?
Actinides. Oh,
Yeah.
no, no, no. See, You're talking about the stability of the neutral elements, right? In the periodic table.
No, yeah,
Yeah.
what are the most unstable ones? Like,
Yes,
is
yeah.
it
That's a very
actinide?
good question. Very good question. No, it's not actinide. Actinides and lanthanides are very rare elements. They are not found in nature so much. They are radioactive. So they have a different story altogether. Your
Oh, right.
chemistry, what you are asking, is easy to understand. You tell me one thing. Losing one electron, losing two electrons, which one do you think is more easier?
Losing one,
Gaining one, gaining two, which one do you think is more easier?
gaining one.
Who can lose one
Yeah.
electron?
Um, or wait, no.
Lithium.
Oh, lose. Oh,
This
and
this
those.
Puri family, this family, right? I said
Oh,
an
yeah,
Hindi word in
lithium.
between.
Yeah.
This complete family, right?
Alkali metals and hydrogen.
Yeah, including hydrogen. They all can lose one.
Hydrogen,
They all can
sodium.
lose one, which is very easy, right? So
Wait,
they
hydrogen can't, right? Because
hydrogen
hydrogen
also
has
can
to
you
make
also
one.
lose one. Remember last
Hydrogen has
time
to
Oh,
make
I
one.
gave this H plus. Aditi, I didn't get your answer last time. Remember I gave you one question. I said put the answer in the chat.
oh.
It's okay, no problem.
Right, I
So
forgot.
these are the
I
one
wrote
which
it.
they are always going to be losing one electron, right?
I wrote it down. I just didn't
Oh,
find it.
it's okay, no problem. So what is this? These are very reactive metals. Very reactive
Okay.
metals.
Oh, okay.
Why? Because they are metals because
Oh,
they can lose electrons and they can lose one electron very easily. So the reactive one can easily, like very easily, it can become stable. Mhm.
Um, I still didn't get one thing about the silicon. Like, why does it have to share? Like, if it already chose one of them, then, I mean, or if it can't choose, but if it already has one, then why does it have to share? Why can't it just like give away electrons
How many
like
electrons
any
it
other?
has to give away?
Well, for the neon, it has to give away 4 electrons.
So after
Yeah.
giving away 4 electrons, what is the charge on silicon?
It would be
Plus
positive.
4. Plus 4.
Oh yeah, plus
And
4.
gaining 4, minus
Negative
4.
4.
I told you that nature is okay up to plus 3, up to minus 3. But it's not okay with the plus 4 and minus 4. Right? Nature
Yeah.
cannot permit this much high positive charge and high negative charge because the energy requirements are very high. Avni, you're understanding? I want you to understand this energy concept, okay? Generally, most of the teachers are not teaching with the energy, but we have to understand why the nature wants like this, like this, like this. And nature is always playing the coin of energy. Energy is like money. So as we spend money, nature is also spending energy, and nature wants to conserve energy. It's not going to throw away energy and like we don't want to throw away our money. Yes, Avni.
So
Hmm.
So like, oh, sorry, you can go, Kaya.
Yeah,
um
Kyra.
so 3 and negative 3 would be the max, right?
Yeah, Max. Yes, yes,
Okay.
yes. In the monoatomic ions. Yes, Avni.
So like theoretically, like what's the highest energy like you can have? Like I know nature won't allow it, but like what's the highest? Like infinity?
No, no, no. Do you know this law of conservation of energy?
Yeah, that it can't be created or destroyed in a chemical change, I think, or chemical reaction.
Law of conservation of energy, not in chemical reaction, everywhere. It's a
Oh,
universal law. So nature has a fixed amount of energy. Like the money, can you print money from your side, Avni? No. Though you are in need of money, there are people who are very poor, they are in need of money. Why can't they print? They cannot print. Because in a country, we have a fixed amount of money and we are circulating that money. Am I right?
Yes.
Like we are working, getting money, getting paid. Your parents are getting paid. I'm getting paid by your parents. So we are circulating money. Am I right? Exactly
Yeah.
in the
Yeah.
same way, nature also has a fixed amount of energy. And nature is using this energy, is taking energy from one point, giving it to another point, then transferring it to another point. But the energy can neither be created nor be destroyed. It can be converted from one form to another form. That's it. That's what nature is doing. That is the reason I said nature cannot handle things in which very high amount of energies are needed, or nature will not permit that. Right?
When you say that nature has a fixed amount of energy, does that mean it can't have any more?
No, it
And
cannot. Yeah,
so if
cannot.
like any light energy from like
Um,
sun rays come, then it won't allow it?
Say again.
So like if any light energy comes from like the sun,
From
then
where? Sun is the part of nature.
oh,
Do you know
right.
that?
Yeah, but can it also
No,
it can
no.
also give like energy.
Universe is nature. Complete universe. Okay?
So
The
the
energy of the
sun,
complete universe is conserved.
so the sun's energy would also be in the
Part of the
energy.
universe, yeah, we are receiving from the nature. And that energy is converted into, photosynthesis.
Yeah.
Food is manufactured by that energy, and that food you are eating, and that food is giving you energy, right? And
Yes.
how are you using that energy of the food? When you are talking, energy is needed. You're walking, talking, your heart is beating, all these things, they need energy. So can you see the nuclear energy of the sun is giving you energy, which you are converting into different forms? Am I right, Aditi? You're understanding right on this law of conservation of energy. Whenever I say law, it means universal law. It means applied on the universe. Anywhere in the universe. Universe means earth, moon, sun, solar system, galaxies. You know the meaning of universe, right?
yeah.
Okay. So we'll discuss more about these ions in the next class. I think I wanted to teach you today how to make the ionic formulas. So we'll start with that in the next class. So you will get a quiz on making of the ions. There is homework posted over there. Don't be scared of the homework, children. Okay. If you don't get time today, tomorrow, doesn't matter. Aditi, you're getting my point? Okay, you can do it any time during the week. So don't take a pressure of homework on your mind. Just do it any time during the week. 7, 8 days are there. So you can use those days to do your homework.
Mhm.
Saturday, Sunday, anytime. So I'm ending the class now. Anything you
Bye.
want to ask? Yeah, bye bye. If you have any question, you can ask.
Bye.
Bye. Bye, Kaira.
Bye.
Bye, thank
Bye, bye.
you.
Bye bye. Bye bye.